In the realm of science and grandiose ideas, privileged insights about what existed before the Big Bang have ignited conversations and captivated thinkers for a long time. This incredible interest doesn't merely test how we might unravel the universe. It challenges the very limits of human understanding. Imagine standing at the edge of existence, peering into the vast unknown, and contemplating what lay there before our universe came into being. The event of the Big Bang marked the dawn of history, space, and everything we know. Yet, what about the moment before? Could there have been a state of nothingness, a silence before the grand explosion? And if so, was it truly empty? Or could something far more profound and unsettling have existed before time itself? As we delve deeper into this question, science takes us on a journey beyond the universe's origin into realms that challenge our comprehension. Physicist Brian Cox, known for his contributions to exploring the wonders of the universe, suggests that something extraordinary might have existed before the cosmic explosion. He invites us to rethink our understanding of reality and existence. In this exploration, we will analyze scientific theories and fascinating mysteries that might explain what existed prior to everything. We'll examine concepts like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may surprise you, but they could also provide new insights into our place in the universe. Prepare to dive deep into a world beyond imagination, a domain of science where the unknown lingers in the shadows, leaving experts both astonished and, at times, unsettled. Let us explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To comprehend what could have existed before the Big Bang, we must first analyze what the Big Bang was. As scientists describe it, the Big Bang refers to the moment when the universe became incredibly hot and dense, expanding rapidly to pave the way for the formation of all matter, energy, and fundamental forces. When we look at the night sky, we see evidence of this hot beginning, with galaxies spreading out from a singular point. But why did this happen? And was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or tranquil. Cosmic inflation proposes that before the Big Bang, the universe was in a state that was cold, empty, and vast like a giant vacuum. However, this vacuum wasn't entirely empty. It contained an immense amount of energy that fueled the rapid expansion of space itself. This expansion, known as inflation, occurred so quickly that it set the stage for everything that followed. In a fraction of a second, space expanded at unimaginable speeds until inflation slowed, and the energy transformed into particles of matter and the forces we observe. But what was the nature of this energy? Why did it appear out of nowhere to create the universe? And why did it stop? Scientists believe that this cosmic inflation created patches of the universe, each undergoing its own Big Bang. Imagine a fabric stretching continuously, with tiny bubbles forming here and there, each bubble representing a universe, including our own. This concept, called the inflationary multiverse, suggests that there are potentially infinite Big Bangs and countless universes. Our own is just one of many. This mind-bending idea challenges our understanding of the very nature of the universe and leaves us wondering what else is out there. The concept of nothingness before the Big Bang is speculative, not factual, based on our current understanding. Even if you remove all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and various forces that form a complex fabric of existence. Even in its most barren state, the universe generates new forms of energy. This fact alone is astounding to scientists, as it suggests that true nothingness might be inconceivable within our understanding. Space itself has properties, rules, and constants that prevent it from being completely empty. Imagine creating a region with nothing in it. No particles, no radiation, no energy. Yet quantum fields and fundamental constants would still exist. For instance, there's a phenomenon called zero-point energy, which represents the lowest energy state of quantum fields. In this state, particles can still spontaneously appear and disappear, creating a subtle hum of activity even in what should be empty space. This challenges our notion of a true void and suggests that, yes, even before the Big Bang, there was something scientists are still trying to comprehend. One of the most exciting theories in modern cosmology is the idea of eternal inflation. If inflation could create our universe, it is possible it could continue indefinitely. Brian Cox describes an endlessly vast inflationary multiverse where universes are continuously created and keep expanding. Imagine each Big Bang as a spark igniting a new universe while inflation continues in other regions, creating countless other universes. This process could, in theory, go on forever. This idea of universes spawning others leads to a striking concept of a fractal universe, where each new universe might create its own Big Bang. Every universe exists as a separate, independent space, unaffected by the others due to the rapid expansion of space. For scientists, this theory is both thrilling and unsettling, as it proposes a boundless multiverse with no definitive beginning or end. Imagine our universe being just a small speck in a vast, boundless landscape, constantly evolving and endlessly generating new universes. And what if the unsettling truth is this? There is no before or after, but rather an eternal cycle of universes forming and decaying. The way we perceive nothingness changes when we consider quantum field theory. According to this theory, the universe isn't merely a collection of matter floating in space. Rather, it is a complex network of energy fields that permeate the cosmos, interacting to create everything we observe. These fields resemble invisible oceans, with particles acting as waves or disturbances. Even when these fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can spontaneously appear and vanish within these fields, briefly borrowing energy before disappearing. This phenomenon creates virtual particles, transient entities that exist for only a moment before dissolving. The existence of virtual particles challenges the concept of an absolute void. Imagine an empty universe where all matter, radiation, and energy have been removed. Would there truly be nothing? According to quantum field theory, the answer is no. Even in a vacuum, these fields remain dynamic, occasionally producing fleeting particles. This constant motion in what should be nothing suggests that the universe doesn't conform to our concept of emptiness. These insights raise a profound question. If quantum fields create particles and particles form matter, could the universe itself have arisen from this so-called nothingness? Adding another layer of mystery is dark energy, a force driving the accelerated expansion of our universe. Could dark energy have existed before the Big Bang? Some theories suggest that the very presence of dark energy today is a remnant of an energy field predating our universe's creation. The properties of dark energy hint at a vast, enigmatic force that might have played a role in shaping the universe before the Big Bang. Some researchers propose that in its more powerful state, dark energy might have fueled the inflationary phase, driving the rapid expansion of space that led to the Big Bang. The existence of dark energy implies that even if the universe were stripped of all matter and radiation, this force would persist, continuing to shape space-time. This raises a significant question. If dark energy existed before the Big Bang, could it have set the conditions for the birth of our universe? Could dark energy be the silent architect of inflation or even the ultimate origin of existence? As we consider this possibility, we confront the idea that dark energy might not only shape our universe's future, but also hold the key to its enigmatic past. Theories like the multiverse, eternal inflation, and quantum field dynamics challenge everything we know about the origins of existence. Each new discovery pushes the boundaries of human understanding, suggesting that the answers to the universe's most profound mysteries may lie far beyond our current reach. Ultimately, exploring what existed before the Big Bang is not merely a quest for scientific knowledge, but also a journey into the very nature of reality itself. It forces us to ask difficult questions. Is there such a thing as nothing? Is our universe unique? or just one of countless others? What are the limits of reality? Science continues to evolve, offering glimpses into these profound mysteries. Each step forward reveals how much more there is to learn about the universe and our place within it. The quest to understand what came before the Big Bang is a testament to human curiosity and our relentless desire to uncover the unknown. The universe itself may hold the key to unlocking the privileged insights of the multiverse. Another theory offers an alternative to the Big Bang as the definitive beginning: cyclic cosmology. This model suggests that the universe undergoes massive cycles of birth, death, and renewal. In this model, the Big Bang isn't a singular event, but part of an eternal cycle where universes evolve, collapse, and then recover. Would you like to expand further into cyclic cosmology or any specific topic within this discussion? Convey proof of occasions that originate before the huge explosion. These waves could, in principle, offer a brief look at what the universe looked like before it became detectable to us, pushing how we might interpret the universe's starting points considerably further. The plausibility of a pre-huge explosion universe is, without a doubt, quite possibly one of the most mind-winding thoughts in current physical science. There are, however, as many thoughts as there are stars overhead. What could have existed before the enormous detonation? Might there at some point have been something we basically can't yet notice or measure? The more researchers look, the more inquiries they pose. Anyway, one thing is clear: this mission for the obscure will keep on filling interest. Furthermore, investigation for quite a long time into the future, as how we might interpret the universe grows, the topic of what existed before the huge explosion stays one of the most significant secrets in science. Speculations like the inflationary multiverse, dull energy, quantum field changes, and cyclic cosmology provide tempting insights, yet no authoritative responses have arisen. Each hypothesis brings up additional issues, testing the limits of our insight and creative mind. The more we get familiar with, the more we realize that the idea of our universe, its origins, structure, and ultimate destiny, might be undeniably more mind-boggling and secretive than we at any point envisioned. For some, the notion that there may be no genuine beginning to the universe is a troublesome idea to acknowledge. The conventional perspective on the enormous detonation as the singular starting point of everything is profoundly imbued in how we might interpret space-time and existence. Yet, as researchers push the limits of material science, it is turning out to be progressively obvious that the genuine story of the universe is undeniably more many-sided. Ideas like the multiverse, in which endless universes exist with their own principles and laws of physical science, suggest that our universe is only one of numerous that may have emerged from a complex, interconnected, inestimable cycle. As we dive further into quantum mechanics, we are confronted with the likelihood that the actual texture of space-time isn't a static background, but a dynamic, ever-changing substance. The quantum vacuum, which we once viewed as unfilled space, is currently perceived to overflow with virtual particles, vacillations, and fields that might play a role in the formation of our universe. These particles pop in and out of existence in a way that defies our conventional comprehension of reality, suggesting that even in the most profound voids of space, there is no true void, only the potential for new states of matter and energy. This prompts another fascinating possibility. The universe we notice today might have been brought into the world from a quantum transformation. In this view, the entire universe could have risen up out of an impalpably small point of highly concentrated energy, with an enormous detonation marking the moment this energy was released. This thought fits within the framework of quantum mechanics, where vulnerability and fluctuation are normal, as well as fundamental to the behavior of particles and fields. Such a scenario raises profound questions about causality and the nature of time itself. If the universe could emerge from nothing, then how do we define what preceded the enormous detonation? The role of dark matter and dark energy in these theoretical hypotheses couldn't possibly be more significant. These baffling forces, which make up the majority of the universe's mass and energy content, remain inadequately understood. Dark energy, in particular, is a force driving the accelerated expansion of the universe. Yet its origins and properties remain elusive. Some researchers speculate that dark energy may have been an essential ingredient in the rapid expansion of the early universe, influencing the outcome of the enormous detonation and potentially playing a role in the formation of the multiverse. Another captivating possibility is that the universe is in a state of constant resurrection, one in which time itself is repetitive. In this scenario, each enormous detonation might be the result of the collapse of a previous universe, an eternal cycle of cosmic creation and destruction. The concept of a cyclic universe challenges our traditional view of time as linear, suggesting that the universe might have no true beginning or end. This perspective aligns with ancient philosophical ideas, where the universe is seen as eternal, with no definitive start or finish, but a continuous process of transformation. As we continue to explore the nature of reality, one thing is certain. The questions surrounding the origin of the universe and what existed before the Big Bang will continue to fuel scientific investigation and philosophical inquiry. Every discovery brings us closer to understanding the fundamental workings of the universe, yet also opens up new mysteries and challenges. As our tools for observing the universe advance, from powerful telescopes to cutting-edge particle accelerators, we may one day uncover answers to these age-old questions. For now, we are left with the humbling realization that we are still only beginning to scratch the surface of the cosmic mystery. Perhaps, in the end, the true answer to the question of what came before the enormous detonation is something beyond our current comprehension, a mystery so vast and profound that it may take humanity centuries or even millennia to fully grasp. Yet, the journey to uncover this secret is a testament to the boundless curiosity and creativity of the human spirit. Truly, endeavoring to comprehend the universe and our place within it is as much about the pursuit as it is about the answers. This ongoing mission to understand the universe is not only scientific, but also deeply philosophical. It challenges the very way we think about existence, time, and causality. What if time, as we perceive it, is merely a construct, a result of our limited perspective within a vast, multidimensional reality? Some theories propose that before the enormous detonation, time as we know it did not exist. Instead, there may have been a timeless quantum state, or even a different dimension of time altogether. Such ideas extend beyond physics and into the realms of metaphysics, where the lines between science and philosophy blur. Ultimately, the narrative of the universe is also the narrative of us, sentient beings capable of gazing at the night sky and pondering its origins. Perhaps that wonder, that ceaseless drive to understand, is the greatest mystery of all. The exploration of what lies beyond the boundaries of our current knowledge intertwines both scientific discovery and existential reflection. Our persistent questioning of what came before the universe, of its true nature, and of our place within it, illuminates an essential truth. The human spirit is as boundless as the cosmos we seek to understand. As science advances, we continually refine our models of the universe. Theories like string theory and loop quantum gravity challenge us to consider realms of reality that are fundamentally different from anything we can currently observe. These frameworks suggest that the universe may not only be more intricate than imagined, but may also be embedded in a much larger, multidimensional structure. The holographic principle, for instance, suggests that all the information in our seemingly three-dimensional universe might actually be encoded on a two-dimensional surface. This radical notion challenges our understanding of space, matter, and energy, forcing us to rethink the very nature of existence. Parallel to these scientific breakthroughs, philosophical and metaphysical questions remain just as pressing. What does it mean for something to exist? If the universe is infinite or cyclic, does it have an inherent purpose or direction? These questions, while speculative, continue to inspire discussions that bridge the divide between science, philosophy, and even theology. The role of observation and consciousness in the universe adds yet another layer of complexity. Quantum mechanics suggests that the act of observation can influence the state of a particle, leading some to wonder whether consciousness itself plays a fundamental role in shaping reality. Could the universe require observers to exist in the way we perceive it? Or does it simply operate independently of any sentient beings, indifferent to our questions and interpretations? As our tools and theories improve, so does our ability to probe deeper into the unknown. The James Webb Space Telescope, for example, is offering unprecedented glimpses into the universe's infancy, capturing light from galaxies formed mere millions of years after the Big Bang. Meanwhile, particle accelerators like CERN's Large Hadron Collider aim to recreate conditions that existed fractions of a second after the Big Bang, shedding light on the building blocks of matter and the forces governing them. Yet, despite these advancements, the ultimate questions, what lies beyond the observable universe, what preceded the Big Bang, and why anything exists at all, remain elusive. Each discovery serves as a reminder of our limitations, yet also fuels the relentless curiosity that defines humanity. This interplay between knowledge and mystery is perhaps the essence of our existence. As we push the boundaries of what we know, we are reminded of the infinite nature of the unknown. This duality, the simultaneous expansion of understanding and mystery, drives us to continue exploring, questioning, and imagining. In the end, the search for what existed before the Big Bang and the broader quest to understand the cosmos is not just a journey outward, but also inward. It compels us to examine our assumptions, beliefs, and perspectives. Whether or not we ever uncover the full story of the universe's origins, the act of seeking answers is itself a profound expression of human creativity and determination. The mystery of existence will likely never be fully resolved, but it is this very mystery that makes the universe, and our place within it, so profoundly beautiful. In our quest to comprehend the cosmos, we not only seek the truth, but also reaffirm the boundless capacity of the human spirit to wonder, imagine, and strive for understanding.